this is Howie. In this video, we're going to connect points on this grid to form four-sided shapes called quadrilaterals. And then we'll discuss the similarities and differences between the many types of quadrilaterals. Let's start right here with this big word looking at you in red, quadrilaterals. Quad, a Latin root word meaning four, and laterals from the Latin word lattice, meaning sides. Put them together, quadrilaterals, four-sided figures. And you can make a quadrilateral by plotting any 4 points on the grid and then connecting them. But in this video, we're going to talk about very specific types of quadrilaterals, ones that have certain properties, and you've probably seen them before. I've plotted 4 points, and now I'm going to go ahead and connect them. This is probably one of the first shapes you ever learned. It's a square. But what are the properties that make it a square? Let's zoom in and take a closer look. All squares must have 4 congruent sides. Congruent is just a fancy word for equal. In this example, each side is exactly 2 units long. The opposite sides of a square are also parallel. That means they can continue forever and they'll stay the same distance apart. In this case, 2 units. The final property about a square that I want to point out is that each of the 4 angles that were formed when we connected the points with lines are exactly 90 degrees. That means they are considered to be right angles. I can prove that using a protractor. Yep, 90 degrees. Let's head back to the grid. In the last example, I plotted 4 points just like this, and I wound up with a square. For this example, let's take 2 of those points and slide them over a little bit. You'll notice that the points are no longer lined up, and I'm not going to have those right angles anymore. Let's go ahead and connect the points and see what we get. It kind of looks like somebody just grabbed the corners of the square and pinched them out a bit. This shape is called a rhombus. Let's zoom in and learn about the properties that make it a rhombus. Just like a square, a rhombus must have 4 equal sides. Also like a square, the rhombus has opposite sides that are parallel. Unlike a square, a rhombus does not need to have 4 right angles. It does require, however, that the opposite angles are equal. In this case, the angles highlighted in pink are both acute angles. That means they're both less than 90 degrees. Aww, so cute. The angles highlighted in gray are both obtuse. That means they're greater than 90 degrees. Back to the grid, and once again I'm going to start out with the 4 points that formed the square. This time, I'm going to take the 2 points on the furthest right side and just push them out a bit. And what shape do I form? A rectangle. Can you compare the properties of a rectangle to that of a square? What is the only difference? Unlike a square, a rectangle does not have 4 equal sides. However, the opposite sides are equal. In this case, the distance along the x-axis is 3 units, and the distance along the y-axis is 2 units. Just like a square, the opposite sides are parallel, and it has 4 right angles. The next quadrilateral I'm going to review has a lot in common with both a rectangle and a rhombus. And just like we did when we adjusted the points of a square to form a rhombus, I'm going to shift the points over a bit so they no longer line up. It kind of looks like a pinched out rectangle. This shape is called a parallelogram. We can figure out its properties by comparing it to a rhombus and a rectangle. Review the properties list for the rhombus and the rectangle. Can you find 3 properties that describe a parallelogram? Pause the video and try it out. Then press play to check your work. Like a rectangle, the opposite sides of a parallelogram are equal or congruent. Like both a rectangle and a rhombus, the opposite sides are parallel. And like a rhombus, the opposite angles are equal. Too acute, too obtuse. I've plotted 4 points again. Right now, they're in the formation of a rectangle. I'm going to move 2 of the points, but this time, I'm going to spread them out in opposite directions. And you might recognize this shape as a trapezoid. This is what comes to mind when most people hear the word trapezoid. But a trapezoid doesn't always need to look this way. Let's use this as our example. And I'm going to zoom in so we can analyze some of the properties of the trapezoid. In this case, the sides of the trapezoid are incongruent. A trapezoid does not need to have any equal sides. It doesn't have any equal angles either. So what does a trapezoid have? Notice how all of the sides aren't even parallel when I extend them out. Do you see how they intersect? Well, to be a trapezoid, all you need is one pair of parallel sides. That's it. There's one more common type of quadrilateral that I'm going to review, and you may have seen it flying around the sky before. Its points may look something like this. It's called a kite. And while it has some similarities to some of the other quadrilaterals, it has a major difference too. Can you spot it? A kite does not have any parallel sides. To understand a kite, we need to look at the sides that are right next to each other. Those are called adjacent sides. And on a kite, 2 pairs of its adjacent sides are equal. And now you have the properties of 6 of the major types of quadrilaterals. Now let's use this list to identify a quadrilateral I display on the screen based on its properties. Be aware, each quadrilateral may have more than one name. Try it out. Can you identify all of the names of our mystery shape? Pause the video to record all of your answers, and then press play to check your work. Let's use the shapes and properties on the grid like a checklist, starting at the top with quadrilaterals. Our mystery shape is a closed 4-sided shape, so yes, it's a quadrilateral. Let's move to kite. 2 pairs of adjacent sides are equal. Well, these adjacent sides are equal, and these adjacent sides are equal, so yes, it also qualifies as a kite. Our mystery shape has opposite sides that are congruent and parallel, and its opposite angles are equal, so it's also a parallelogram. Let's take a look at the properties for a trapezoid. For a shape to be a trapezoid, it needs exactly 1 pair of parallel sides. Our mystery shape has 2 pairs of parallel sides. It is not a trapezoid. All of the sides on our shape are 3 units, and it meets all of the criteria to be a rhombus. So we can also call this shape a rhombus. Our shape has opposite sides that are congruent and parallel, and it also has 4 right angles, so it qualifies as a rectangle. And because our shape has 4 equal sides, it meets all of the property requirements to be a square, and that is the final classification, so we will refer to this shape as a square. Because it meets all of the properties of a kite, a parallelogram, a rhombus, and a rectangle, a square can also be considered all of those shapes as well.